Good night, teachers and compañeros. And we are Gerard Tirán Méndez Morales, Rigel Antonio Pech Ek y Suelen Ricalde Cruz. We expose to yourself the network theorem. Intelligence theorem. Intelligence theorem states that in an electrical network with the B branch and L message, the following is true. We can see the equation where JK and VK represent respective J, the electric current and voltage of the kin branch. This theorem is closely related to the principle of conservation of energy, since the product of Jk and Vk represents the energy per unit time that is supplied or consumed in the key branch. The equation states that the power that is supplied to an electrical network is equal to the power that is consumed in that network. This theorem is general in nature and can be applied to a linear or nonlinear time invariant or time invariant electrical network. The only restriction is that Kirchhoff laws must be satisfied. The electrical network must be of concentrated parameters and deterministic. Consider an electrical network of B branch and N nodes, which simple therefore and that number of message is L same B minus N minus 1. Without considering the external mesh is assigned the N número L más 1, let E and IB be the mesh currents of the A and B message, respectively. Yeah. Suppose the branch K is show figure 3 and current is circulates the current JK when the voltage is VK igual a VAB. Can you see the figura 3? Then JK UK is igual a entre paréntesis A un símbolo raro menos IB entre comillas, bueno, entre paréntesis VIB can also be written as 10. Adding questions 4 and 5, can you see the difference? And we considering the braces and one meshes of the electrical network. Equation C can be written as follows, where for H is the sum of a branch voltage of the mesh and for each. Everything before is the sum of a branch voltage of the mesh. Since Kirchhoff laws have been assumed to be satisfied. Of the second law, each of these sums equal to 0 and therefore Hello, I am going to tell you theorem of substitution. The theorem is general in nature and can be applied to linear or nonlinear time invariant or time invariant electrical networks. Its application is related to electrical networks of concentrate parameters. In other words, satisfying Kirchhoff laws and also being deterministic. In other words, that there is no uncertainty about branch voltage and currents. Um, Proof of the theorem. Consider an arbitrary branch K which is not coupled to any other branch of the electrical network. Let Jk be the current circulating through it and big K the voltage present between its terminals. Suppose that such a branch is common to the meshes and B, as shown in figure 1 for the mesh and A of Kirchhoff's second law. We have, can you see in figure 2, for the mesh A of Kirchhoff's second law, we have, can you see in figure 3, if the K branch is modified by paralleling an either independent voltage source of value vacate, as shown in figure 2, equations 1 and 2 remain unchanged. In figure 2, the above equations are not modified. In figure 2, A is arbitrary electrical network, B is ideal independent voltage source in parallel with an arbitrary electrical network. Um, M, M is arbitrary power grid, and C is equivalent power grid. The electrical network in figure 2 is equivalent to the electrical network in figure 2. This is demonstrated by applying Kirchhoff's first law to the nodes 0 and 02. In each Kirchhoff's first law to nodes 1 and 2 in each of the electrical networks in the figure. As a consequence of the above, if the electrical network N between the nodes 1 and 2 is replaced by an ideal independent source of voltage of value Pk, the Kirchhoff laws of the original electrical network are not altered. The proof of the theorem, when the substitution is carried out by an ideal independent source of current, is completely similar. Reciprocity theorem. It states that in any branch of an circuited network, the current due to a single voltage source, letter B, in networks is equal to the current draw. The branch in which the source was originally placed when the source is placed back in the branch in which the current was originally obtained. The theorem is used in the bilateral linear network consists of bilateral components. In simple words, we can state reciprocity. The theorem is that when the voltage and current source locations in any network and interchange, the, the amount or magnitude of current and voltage flowing in the circuit remains the same.
This theorem is used to solve many DC and AC networks that have many applications in electronics. Your circuit has no time varying elements. Proof of the theorem. The location of the voltage source and the current source can be interchanged with a change in current. However, the polarity of the voltage source must be identical to the direction of the branch current at each location. The reciprocity theorem is explained with the help of the circuit diagram shown below. Um, can you see the figure? The different resistors R1, R2, and R3 is connected in the above circuit diagram diagram with a voltage source, letter V, and a current source, letter I. From the above figure, it is clear that the voltage source and current source are interchanged to solve the network with the help of reciprocity theorem. And steps to solve a network using the reciprocity theorem. Step 1. First, select the branch between which reciprocity is to be established. Step 2. The current in the branch is obtained using any conventional network analysis method. Step 3. The voltage source is exchanged between the selected branch. Step 4. The current in the branch where the voltage source previously existed is calculated. Step 5. Now Now it is seen that the current obtained of the previous connection, and in step 2, anti-current that is calculated when the source is swept. In other words, in step 4 are identical to each other. And if students aparte, thanks for your attention.